So O.J. Simpson died.
He sure did. Took him long enough.
It was about time.
We'll never know who the real killer is.
He posted that Discord. I'm like, if the clothes don't fit, get out of here with that.
We're ready for you to start, sir.
Are we ready?
Yeah.
All right. 14 minutes after. Pretty good.
It's a new personal best.
I'm glad. Okay. All right. So hi everybody, and I guess whoever is watching. This is a talk about observability, and basically what it's going to be about is observability is an abstract concept, some concrete examples of how we do observability along with the benefits and problems that come with that. A bit of talk about how we do observability within Azure, what the options are, what are the ways to deal with costs, what the benefits of certain logs and metrics and all of that are, and then a little bit about where the future of observability is going. So my name is Mike Schlegel. I've had a bit of a weird journey to get here as a person talking about observability. My first degree was in history. That got me into building material sales, which I didn't like, which got me into project management in industrial installation, which I didn't like, which got me into a computer science degree, which I did like. And after that, full stack development into a really fun job as a full stack developer doing mobile apps, at which time I came to Humana and started doing architecture, which I didn't know how to do. I learned how to use Terraform, learned all about how a large company deploys its infrastructure, and then moved into observability. And I have been in observability for 2.5 years now.
The longest anyone has ever been in observability.
That's why I'm doing the talk. So what is observability? Mostly we talk about logging, monitoring. Those are two components of observability. Observability is a term that's, I don't know how long it's been around, but I never really heard it until I got into this space. It's a way to basically express your ability to understand your system at any given time. And the only way that you have to understand that system is by the data emitted from your system. That's your telemetry. That comes in 3 forms: metrics, logs, and traces. These all have different functions. We all kind of know what these are. Anyone in IT is going to know what a log is, right? That is a piece of information about some event in your system. A metric is a piece of information about the performance or health of your system. And a trace, you may not know. A trace is sort of like, think of a stack you get, a call stack you get after you have an error in like your application. You get each event in order showing you sort of what happened, right? And you get this whole set of events up to the error. Traces are basically a set of spans, we call them, but it's a set of events with a correlated ID. So say I have an API and I get a request in, and then I do some logic, and then I go to the database and I pull some data, and then I come back and I do some more logic, and then I answer the request. Each of those events can have a single trace ID attached to it so that you understand the entire loop of your data, what was called and what happened. Therefore, when you get downstream and you're trying to analyze why your database error occurred, you can look at the events that happened in your API that called the database and that received the database data back, and be able to correlate all that data into sort of a larger picture of the system mapping and what happened on the route along the way. So generally observability, like what the problem we're trying to solve is that if you don't have a good idea of what your system is doing and you're not able to understand what's happening within it, then when problems happen, when errors happen, when outages happen, you are either unaware of them or it takes you a long time to figure out what happened, and then a long time to figure out how to resolve them after you figure out what happened. So the goal of observability is really to take that understanding of the system and make it proactive and real-time and comprehensive. There's several different kinds or flavors of observability, I would say. We roll them all together, but there's different sort of operations and sort of team functions around observability. Security, operations, and app teams. These all have different needs. They're all trying to solve different problems. Security teams are trying to deal with threats to the system, bad actors, people sending phishing emails or ransomware attacks, anything along those lines. That's what your security operations center is doing. They're building out detections on all the logs. They're looking for anomalous trends. They're going 9 months back and looking for things that happened in the system then to see if they can pinpoint someone's doing something now. All sorts of really interesting stuff. But they don't, for example, care about, say, what the health of app X is. That doesn't matter to the security team. Operations, however, might be very concerned about app X. App X makes the company money. So in that case, where the performance is on that application is incredibly important. They want to know, how much CPU it's using, how much memory it's using, how long requests are taking, what does that latency look like, database request, API request, whatever it is, right? So there's all sorts of thresholds that they can define to understand what's going on with their application. App teams usually just want to know what's happening with their app specifically, but more from a functional standpoint. I just ran this out in non-prod and it's not working. I need to find that. I need to comb through logs. I need to know what's going on. With observability, we're generally serving security and operations. App teams, although we want to help out our app teams and allow them to do that, you just want to allow them to do their job. But from an sort of, on our side, from an enterprise standpoint, when you're looking at the whole of the company, those teams can kind of take care of themselves. As long as your operations teams are able to support those, then you want the app teams doing whatever makes sense. The end goal of this, I've got MTTD and MTTR listed here. Those are mean time to detect and mean time to resolve. Those are the two biggest metrics that we hold ourselves to. That's really the end goal of observability. How long did it take to detect there's a problem in the system? And then how long did it take from that point to resolve it? There's lots of other MTTXs out there. Mean time to know or mean time to understand is a popular one. So that's after you've detected it, how long does it take you to actually understand what the problem is so the resolution can start? So one of the things we try to do is set up actual projects within observability that go towards how do we reduce these? Because when you get to the end of it, your company, no matter if they're as big as Humana or they're fairly small, if your main application that makes money goes down, you want to be able to resolve it as fast as possible. And your state or maturity of observability is going to determine how well you're able to do that. Getting down more into the sections of observability, logging, infrastructure monitoring, network performance monitoring, application performance management, and digital experience monitoring are the main categories that we focus on within observability to get a holistic picture of our systems. Business activity is one that a lot of businesses like. Tracking how many phone calls you're getting, how long it takes the phone calls to be returned or resolved or whatever. This is like a business activity, but it can give you some good insight into how well you're doing with a call center, say, which allows you to then take a look at your bottom line and say, well, how can we improve this system? So there is observability outside of just the operations and security aspect. There are ways to use observability in order to get insights into your business as well. So I wanted to talk a little bit about how, in general, we do observability well, or at least how we try to do observability well. First and foremost is some kind of standards around how you're going to do it. One of the main problems with taking, especially in a big company, with putting observability together is it gets complex and complicated. And if you don't have standards around how you do things, how they're formatted, what the data looks like, what should be in that data, you end up with a mess. You are unable to correlate events. You are unable to use the same systems to deal with those events. And you are basically hamstringing yourself by allowing anything in the system source-wise to be sent to your systems without knowing how that's going to look. We have a lot of problems where we have to build out data models for everything that comes in, and we have to find out what fields that source has, and we have to figure out how that's going to look, and then we have to set that up, and then if it changes, we've got to redo that. If you have a standard format and it's standard across your environment, then it's always going to look the same, and it makes it a lot easier to understand what data is coming in and what fields you can always look for. Good data that's centralized. One of the policies that security often likes to implement is, give me all the data. I will figure out what I need. I probably need everything. If an incident happens, I want to be able to look at absolutely everything that happened during that time frame. It is not a manageable approach, though. It is costly. It gives you a bunch of noise. Noise is a huge problem that we try to reduce within observability. And you end up with all of this data that is useless to you. You might have 10 events or out of every 100 that are actually useful. If that's the case, then you need to be filtering for those. You need to be taking a look at those and trimming out the data that you don't need within those events. You can transform some things to, say, add metadata that would be helpful to you to understand that event, and you can merge like events. So one of the ways to really help with your data is to, between the source and the destination, filter it, trim it down, get it to the most pure form you can. This is the ideal, right? This isn't what happens in practice, but the ideal scenario is to get to that point where you are sending this really great data every time that makes sense, that is useful, and that your alerting and operations can actually use. Which brings me to relevant alerting. This is a big problem we deal with at Humana, is that we have thousands and thousands of alerts going off all of the time at different criticalities, different problems, different thresholds that have been hit. Relevant alerting is super important because you can gather all this data, you can make it really good data, and you can put it all together. But if you're streaming 2,000 alerts an hour to your operations center and every single one of them is critical, then nothing is critical, right? So it's very important to have standards around the alerting. It's very important to constantly work on continuously improving your alerts, going through, making sure that alerts that are firing are useful. It's a task that needs to constantly evolve within your observability operation, or you just increase the noise level year over year over year until it is completely unmanageable from the operations side. To help do that, appropriate tools and technologies. At Humana, we're using Splunk and Dynatrace, but there are plenty of tools out there, open source tools like Prometheus and Grafana. In Azure, which we're going to talk about, you've got Log Analytics, you've got Sentinel, Azure Monitor, Defender for Cloud, et cetera, et cetera. Learning these tools, deciding on the one that's right for you, and then implementing them with all of the functionality they have can really help with all of the pieces we've already talked about. And finally, I'll say that automated instrumentation, from my perspective, is one of the very important parts of a good observability practice. If you are having infrastructure teams, platform teams, app teams, operations, if you are having them install and do the configuration for your collection and transport of data to the destination, you're going to have inconsistencies. You're going to miss things. You're not going to understand your own coverage. So in order to get to a spot where you know that the collection of the data is properly configured, is going to be done correctly, is always going to be on, and any resources, You need to automate that instrumentation. So let's talk about how this is generally implemented in Azure. This is a busy slide, and I'm not going to go talk through every pieces, but kind of the point I was trying to get across here is that Azure has a lot of resources that allows you to do monitoring and allows you to do observability. Azure Monitor in general is the big umbrella with all the functionality that allows you to collect logs within Azure, move them to the destination of your choice, analyze them, and do analysis, or I said analyze, security operations, detections, and alerting. So data sources are everything you can have in Azure. Your applications, your containers, any of your compute, all of the PaaS services that Azure offers, your subscriptions, your intra ID from your tenant, everything you want to know about what's going on within Azure can be collected and can be sent to whatever repository you want. One of the interesting things with Azure too is they are building out the Microsoft Graph API to allow you to collect a lot of this data via API calls. You can collect metrics from most of the resources in Azure simply by hitting the Graph API. You can collect a lot of logs that way too, like Microsoft Office 365 logs can be collected through Graph API. So Microsoft is working to continually build that out. And ideally, this will make it a much easier process in the future to sort of collect what you need and only what you need, with you in control of how you're getting it. However, one of the nice things with Azure is everything's very, very out of the box if you use their tools. These are the main ones. When I started in observability at Humana, we had a humongous, well, we still have a humongous Azure presence, but we were using Azure tools to monitor Azure. All logs filtered to a centralized log analytics workspace, which had Sentinel attached to it. When you set up Sentinel, it's enabled in your tenant. You simply attach it to one or more log analytics workspaces, and then you start working with Sentinel. There's a bunch of out-of-the-box solutions within. You can set up connectors that are pre-configured that allow you to just get other pieces of information you want into Sentinel, and that allows you to do your security detections. In addition to that, Defender for Cloud is this amalgamation. I'm sure you guys have seen this if you're in like Azure infrastructure or anything. They're taking components they have, resources they have, and bundling them into packages that work really nicely. Think like Synapse Analytics, right? So Defender for Cloud is basically what you Defender for Endpoint, Defender for Office 365, Defender for several other items packaged as one big security tool. And this is your way to manage your threat detections within Azure and your exposure to the outside internet, right? In addition to that, application insights. This is one of the great tools that if you are an Azure app team, you love using. This gives you all the performance data about what your application's doing, along with the logs stored in Log Analytics Workspace. So you're able to troubleshoot, you're able to monitor, you're able to keep tabs on your Azure application right there. The way we do it, you put it right in the resource group next to your app, and you've got all of your data right there for any of your app developers to use. Log Analytics charges anywhere from about $1.50 to $2.50 per gigabyte for ingest. So one of the problems is, how do you manage that Log Analytics workspace? How do you manage the cost for that? You want the correct logs in there, especially if you're running Sentinel. You need the correct data for security purposes. You also will want to use the Log Analytics workspace for analyzing logs. It is a very powerful querying tool. It allows you to set up alerts. It allows you to set up workbooks, which allow for dashboards. The workbooks are amazing, and there are a bunch of out-of-the-box workbooks that will give you full comprehensive look at your system, your sources, what things are doing within Azure. It's a very powerful tool, and the way you need to manage it is simply taking a look at what do I need within this workspace and when do I need it. If you need things, if you need logs, if you need to be able to look at something at any given time and analyze what's going wrong with it, those are that's the data you need in Log Analytics Workspace. Those are the things you're going to be accessing all the time. However, if you need logs to be queryable and searchable, but are only looking to do that at specific times, or if something goes wrong you're not expecting, there's a better solution. It is not as streamlined and flashy as Log Analytics, but it works very well, and that's the keeping data in pane here. Azure's got a product called Azure Data Explorer. It's actually the base of what Log Analytics was built on. So it is basically a tool that will ingest data, put it into tables in Azure Blob Storage, and then allow you to use the same KQL language that Log Analytics uses to query your data. It has two it has one big downside, and what that is it doesn't come with the tables out of the box. You go into Log Analytics and you just enable that you are sending, let's say, firewall logs there. There's a firewall table, everything shows up nice and pretty. Log Analytics will even add metadata in there, like your subscription ID and the tenant and like things that don't show up in the actual JSON object, right? You get the raw JSON object in Azure Data Explorer, and you have to build the table yourself. So the way that we did this was we set up a couple of raw tables. We streamed the data in through Event Hubs. You can send any diagnostic data to three places: Log Analytics Workspace, Storage Account, Event Hub. If you are wanting to get data out of Azure or into something in near real time, Event Hubs are the only way to do that. So we set up these raw tables and then had functions that will look for specific types of logs and push them into tables that were set up for them. Now what we have is a functional Log Analytics Workspace at a fraction of the cost, where we can go and query our logs in the exact same language we would do in the Log Analytics Workspace. So if you're ever in a spot where you know that you want to use Log Analytics with Sentinel, but you need other logs held for compliance, for forensic auditing, or trying to find out even if you're just like trying to troubleshoot function apps, that data's in there, but you don't need it all the time. So you've got a very inexpensive way to do that. One of the other sort of pipelines we set up was, if you ever need to get data out of Azure, we needed to get, for security purposes, Azure Intra ID logs, Azure Activity logs, and a bunch of other security required logs out of Azure. Again, this was an interesting prospect because we had to stream about 4.5 terabytes a day of data out of Azure. So what we did was set up again, Event Hubs. We sent a lot of data. We sent the data to the Event Hubs. Then we created function apps. The function apps listened to the their paired Event Hub basically, and then all they did when Event Hubs get events in from Azure Monitor, they put them in an array of JSON objects. So the function app would just parse through, grab all of the individual events and push them up to our Splunk instance. You got to scale out appropriately. You have interesting ebbs and flows depending on the time of day. So there can be a lot of configuration to go into it, but once you got it tuned pretty well, it works incredibly well and is a pretty resilient system. So also want to talk about the future of observability and where it's going. I'm sure a lot of you guys are familiar with the Cloud Native Computing Foundation. They're biggest open source project is Kubernetes. That ring a bell, Cam?
Yeah.
Their second largest, their second largest project is OpenTelemetry. So there was a couple of projects on there. One was called Open Census. I think the other one was Open Monitoring. They pulled these together and created OpenTelemetry. The idea is to have a standardized set of APIs, SDKs, and collection mechanisms that you can use in any cloud service provider that will work together and make sure that you are getting standardized protocols and formats of logs from your sources, no matter where they are. Azure, or Microsoft, I should say, is one of the largest contributors to this. Vendors like Splunk and Datadog and Dynatrace are big contributors to this. There is a lot of push within the cloud service provider community to instrument this within their cloud service providers. And Azure Monitor is adding this in slowly but surely. So right now, if you're standing up an Azure or like just an Azure app service, you can use a Microsoft distribution of the OpenTelemetry SDK that will work seamlessly with App Insights. So it'll do all the collection, but you get them in what is called the OpenTelemetry protocol, which will allow you, if you need to in the future, to send those somewhere else and know that they will look exactly the same because they're going to be in that same protocol. They'll work with other tools because they're in that protocol. It's a way to sort of remove the vendor lock-in. And these vendors, like Microsoft, like Splunk, are not fighting this, they're embracing it. They want to be the destinations. They still are going to charge you for getting data into their system and analyzing it and everything. But this is the path forward for collection, transport of data. And it's really cool. The OpenTelemetry collectors, and we use them in our Kubernetes clusters at Humana, have three components. They have a receiver, a processor, and an exporter. And so receivers do exactly what they sound like. They receive the data. So for example, in a Kubernetes cluster, the receiver goes into a file path defined by default in Kubernetes that goes and pulls any standard error logs, but you can add other paths. That's the receiver for Kubernetes. That gets the data in to the collector. Then you can do processing. You can do that filtering we talked about, or the trimming or the enhancement to the data within the processor, and then you can export it. Every single tool and that's out there that's part of the project has an exporter. So Splunk, Hack Endpoint, Dynatrace, OneAgent, Microsoft Log Analytics. So wherever you want to send your data, you can. And that's the beauty of OpenTelemetry, is it just allows you to control and own your data and send it wherever you want. And it's always in the same format and protocol.
So is this like attached on the resource, or is it like centralized and like it goes back to the centralization and then it does the processing and then sends it back out to the destinations?
There's a couple of ways to do it. So OpenTelemetry collectors can be deployed as an agent. So on the resource, so we deploy, on our Kubernetes clusters, we deploy it as a daemon set, right? And then so it puts a pod in each node and does the collection there. On VMs, we deploy it as an agent that simply does the collection on the VM and gets OS, host level metrics, whatever you want to configure it for. Okay. One of the options, though, is to deploy the collector as gateway. So you can host your own OpenTelemetry gateway and centralize where all of your collectors are, agent collectors are sending their data. Do more processing there if you want. Do a single export, right? So instead of configuring it everywhere on every single agent, I can just configure exporting in the collector gateway.
Yeah, this is just like if you had a bunch of data and you wanted to process it before you sent it to where it costs real money, where you're like, hey, I don't want to send it to this place because it's super expensive here, but we'll process it all over here.
Well, that's why the gateway is so nice, because you just set your whole organization to send it to the gateway. The gateway takes care of caching and like it adds resiliency because it can start like backlogging stuff if it needs to. You don't fill up memory, which that was what happened in.
It's incredibly lightweight too. It's
Yeah.
really impressive how efficient it is at doing the processing. There's no overhead to it.
How often does the tooling around collection and processing get in the way of MTDD, right?
Well,
Right, because you're just sending it, oh, oops, I'm sending it to a black hole because the entire processing is 500 erring. Right?
okay, so you're saying if like,
Who's monitoring the functions that are monitoring the output?
The process doesn't have good
Hey,
observability.
we didn't get any logs about our logging being down, guys.
Right, as you're sitting there talking about Azure functions, pulling data out of event hubs, I'm going, okay, well, what's watching those?
yeah, okay, well, you can't inception this thing to, all the way down, right? At some point, you just have to say, this is how we watch things. We do have observability on our observability tools, right? We monitor that egress, that pipeline I showed you where it was event hubs functions and getting out. We monitor that, right? We have alerting set up on that. If it starts erroring out, at least we'll get those alerts, ideally.
Maybe.
Well, the concept in alerting too that we have. So if we stop getting logs from the functions, like that's an alert, right? No logs are there.
The lack
The
of
lack-
logs.
When
the lack of
the
logs.
Splunk salesperson calls us and says, hey, you didn't send 4 terabytes today, and I'm expecting that money. That's when you know.
Your spend is down
Oh,
4,000%. Your spend is down.
That's the biggest alert.
No, I guess so. As you architect from the complexity of the main apps,
Mhm.
do you actively attempt to reduce the processing complexity as you add observation layers on,
Yeah.
so
Yeah.
that you can eventually get to something that's atomic that says, look, this is either going to work or it doesn't work, and doesn't have any interim states.
Well, and the ideal really is to say like every single app just has the same OpenTelemetry SDKs running on it, right? So they're all instrumented the same way. OpenTelemetry is working on a process they call zero instrumentation. So for a lot of the collectors, what they can do now is they will go out into say you're in Kubernetes. It will look for runtimes for Java, for .NET, for Python, and it will attach to those runtimes and pull data from the runtime so that the people who own the app don't actually have to instrument anything.
You can do that with application insights.
You can do that with application insights, yeah.
.NET framework, it'll just go in and suck data out of the.
Well, that's
Except on Linux containers. Ugh.
Okay.
They're running an app.
Well, and like I said, like
There was a problem there.
if you go look for it in the Azure documentation, they've got the OTel distribution for any of their .NET Core, .NET, Python, like anything that they run and any of the languages that you can deploy App Insights into, they've got the OpenTelemetry distribution for it, and it'll work with App Insights. But if you ever decided you wanted to send that somewhere else, you wouldn't have to re-instrument.
Is Google Analytics following suit?
I think they're the furthest behind. AWS is probably the furthest ahead. They have quite a bit of instrumentation available out of the box from OpenTelemetry using their distributions. Now, none of these tools are moving towards anything outside of the collection mechanics, and their distributions want you to use their analytics tools. However, any of these distributions, you can just add on an exporter, right?
As an app developer, it's any kind of web app. You put Google Analytics in it because you want a lot of the analytics that Google provides.
Mhm.
Then you put App Insights in it so you can get the crash and the debug stuff that you really need. And you need half from over here and half from over there, and neither one of them wants to play nice together.
Yeah.
Well, correlate between them.
And you can't correlate between them.
That is why
They both hate each other.
That is why OpenTelemetry is so nice, because you can send it to a collector and then have that send one way and one. Although the Google one doesn't work that way.
Yeah.
Because they actually put a little iframe in your app, and do some massive spying on your users.
Analytics stuff, yeah.
Yeah.
OpenTelemetry will also put trace IDs, like it does tracing.
Right.
So it will add the trace IDs as it goes.
Yeah.
And it collects what's called baggage within OpenTelemetry, where it will take important information that wouldn't normally go from like this API to this API, and it'll bring it along because it's part of the, like you wouldn't understand the connection without that baggage. So there's all this built-in functionality that if you have instrumented this across the board in your system, you get sort of this full set of tracing that can really help you correlate events and really reduce your time to detect and respond to these events.
That kind of end-to-end picture that you just painted, taking you from the beginning of an event that the user maybe clicks on a button and that calls, an API, which, as you said, does some logic, goes to the database, gets some database, does some stuff with that data, maybe sends it back, maybe it sends it off somewhere into a queue, et cetera. Is that kind of the scope of that, or can that be expanded to say, hey, this is the trace data for this user's entire session? All the things they do.
It can. Yeah, it can be. It depends though. Like a user's session and how that's tracked is going to be different from like API requests and calls, right? So the user's session, you might see that they made a call, but then the events of that whole call would probably be a separate trace.
And there's nothing out of the box that ties those multiple events within a session together.
Well, that call would be the one that the call on their end on the session and the start of that trace would be like.
There's nothing that ties multiple calls within a session together.
No. Now, that's not to say you couldn't set that up.
You could build it, but it's not.
You could build it, but it's not out of the box.
Immediately made me think of the product Full Story. So Full Story tracks your mouse. You can even set it up to track eyeballs if there's a camera, and how you move across a page in a website, and sends that as telemetry until you click a button, and then something else picks up. Google Analytics picks up from clicking the button, and then the APIs, Application Insight picks up from executing the APIs. And how do you pull all of that together into one seamless log that shows what happened?
So that's digital experience monitoring. It falls into that bucket. Well, that's the whole problem for event correlation, right? Event correlation is how do you take all of these disparate events, and even if you've gotten good tracing, how do you, especially at a company the size of Humana, where like your unified login is this whole humongous thing, and then some of your applications are enormous, and you're going to Azure and you're going to the data center and you're using some tools on GCP or whatever. How do you pull that together? And so there's event correlation tools. They leverage AI ops, that leverage machine learning, and they've got these really interesting tools that allow you to sort of take fields around, like if your CMDB is good and has like a lot of great data in it, like you can correlate those CIs. You can add fields though within the system to start like tying things together. And as you start building out the functionality of that correlation tool, correlations you didn't expect to happen start happening. And you can get service maps, right? So that you can see like a visualization of sort of what happened with a set of calls and like how all of this data happened and like where the issue is, It's one of the things, like some of the tools we use build these out as you go. So as you start building correlations, as you start having events happen, it'll build out service topologies for you and allow you to see where problems are visually, which is a really nice way to look at it. And it allows you to start reducing your noise because it'll start bringing alerts that happened in A and B and C. And it says, I'm bundling those. I'm bundling all those alerts as a single alert. That's a big way that we reduce alerting noise is you get 50 alerts in, but it's all from the same system. And then 50 more alerts in there. It's all from the system the database that it's talking to. It'll just bundle those, right? If you've set up a couple of things correctly, it'll bundle those up and say, I've got one problem here.
So when you talked about like standardizing the logs or adjusting them, like what are some common fields that you normally like trying to standardize? You're like, date,
They're gonna
time.
see it so easy, right? You need a timestamp, right?
Yeah.
You need to know the source that the data came from. For your business, you might want the CI or an app ID, right? And you may want to know, like, depending on the type of source it is, you may want to know something else. What's the host name on this server, right? I always want the host name in the event. I never want to not have it because I'm doing a correlation on that field. Or like, I'm not thinking of other ones off the top of my head, but it's that kind of base level where you just want to know, like, I want to know when it happened, I want to know where it happened, and I want to know like what your identification is within the system.
Okay. So like you're normally like, that's why I was like, whoa, I wonder what standards would you be looking for in every log
That
to
kind
be
of
able to
stuff.
like force it. And then like if a log doesn't have it, then you're like, all right, well, because I have this agent on here, I can use this agent to generate the data that this log's not making.
Well, so one of the things we're working towards is that metadata being something that the app team doesn't have to instrument, or whoever's running the server doesn't have to instrument. The collection agent can go find it and just add it in.
Got it. Okay.
So especially for things like I get a win event log, that's going to have all the information Windows thinks I need, but it's not necessarily going to have a couple of fields that I want when it gets into my analytics tool.
Doesn't matter, Kevin. None of it's FIPS compliant.
My life isn't always going to be this. I mean, it has been so far. You're right.
All right, they're gonna put AI on top of it, and then those AIs are gonna get in touch with other AIs, and
There you
you
go.
know,
All done.
we're just running straight long.
And then
We don't know who scorched the skies.
The AIs will be hosting the meetup groups.
But it was at
talking
that
to each
moment,
other.
but it was at that moment we realized we screwed up.
Is that the whole thing, the top to bottom, the left to right?
That's it.
Awesome.
Thanks.
So where is Microsoft Win Open Telemetry as a target of diagnostic logs?
Just in time to migrate again.
Your problem until, as a speculating here, but a senior director of cybersecurity wants to, I don't know, get some logs, take a look at some data and see what bad actors are in his system.
Then I know a thing or two.
Who's asking?
It's senior director, by the way.
You'll at least have resources to deal with it.
Like,
Yeah, money and people and whatnot to go look at it.
money and people, the things you need to get stuff done.
When it makes you think on the small side of it, where I'm firmly in. There's people just running their companies and they just don't even know they're at risk. And even if they knew they were at risk, they couldn't do anything about it because there's no budget anywhere in their corporate finances at all to even address it.
Ignorance is bliss.
Ignorance is bliss until it bites them in the ass.
No, I mean, almost every high profile
It's better for me to not
exploited,
know.
every high profile company has been exploited.
Yeah.
They just learned.
Only
Yeah.
because it's
They learned the hard way.
I got an email today that this business's customer was getting text messages over a cell phone asking about payment for an invoice. And the text message was using people from the company.
Well, did you see
And I'm
the,
like, oh shit, how the hell's that happening?
no, did you see the Zoom call one? So there was a Zoom call where they set up a bunch of people to be on a Zoom meeting, and one of them was posing as the CEO who like was really mostly like through email, and he like called the person in and they're like, oh, we need to transfer this amount of money to this vendor and it needs to happen like right now. And
Somebody did it?
yeah, they did it.
Yeah.
They
I see
transferred it
those all the
because they
time.
were.
CEO was using the emoji con where he's like a fox. They're like, oh, it's classic fox guy. Classic CEO.
Yeah.
As soon as the first of the year came,
You think anyone who transferred money for their company would be very good at CYA
nope.
and say, send me that and write it and you got it.
As soon as the first of the year came around and you start having to hand out W-2s, everybody starts looking at their W-2s. So all the spam for, hey, will you change my direct deposit? Starts coming out in force. Many companies and a few that are my clients, they're accounts payable people, they're human resources people. They just failed. They just changed the CEO's bank account to go somewhere else because they got an email. And they were too afraid to question authority.
Yeah.
It's a culture that usually destroys all of that.
There's a lot of vulnerabilities in security, like lots, and culture.
You're about ready to walk in. Culture is a huge one.
It's a huge one, yeah. It's listed in one of the top threats for
People 7 ranks down from the CEO, and the CEO is, sending them an email. Just do whatever they're told. Doesn't matter what it is, they just do it, and they never ask. And welcome to cybersecurity. You're gonna have fun in cybersecurity.
I'm gonna turn off the stream. Nice job, sir.
Nice job.
Good job.